Conversations, we're joined by a very special guest. He's the current Director of Research in the Chemical Engineering Department and Head of the Fluids Division. He's served as a Director of Undergraduate Studies for 3 years and has been a Professor of Fluid Mechanics for over 10 years with specialities in multi-phase fluid flows and interfacial fluid dynamics. He's published over 200 papers in the leading journals of chemical engineering with over 5,000 citations, and he was recently appointed as the Vice Dean for Education at Imperial College London and also holds the prestigious position of Patronus Royal Academy Chair of Fluid Dynamics. It's our absolute pleasure to welcome Professor Omar Matar to our show. Omar, thank you so much for coming.
Hi Ravi, thanks very much for the introduction.
Thank you. So, I'd like to start off by first congratulating you on being appointed as Vice Dean. I mean, wow, what a tremendous achievement, and I'm sure you, like all of us, must be very proud to represent the college in this way.
Absolutely, yeah. Thanks very much for the introduction. Yes, I think this was a real honor for me to be chosen as Vice Dean. There's a wealth of talent here in engineering in the college, and for me to have been chosen to be Vice Dean, I think is a great honor for me. Thank you.
I can imagine. And what kind of new roles and responsibilities does your new position entail, and who will you be working with in the college?
Right, so the new position kind of builds on my past experience as Director of Undergraduate Studies. So I was Director of Undergrad Studies between 2007 and 2013, about 6 years in total. And then I had a break from that space and I kind of came back to it. But I would say that the new role entails working very closely with colleagues here in the faculty, so Directors of Undergraduate Studies, also the Associate Dean for Education, also the Head of Education, as well as the Vice Provost for Teaching and Learning, Professor Simona Botendijk. And what we want to do is effectively allow the students to have a really good time here and get a fantastic degree. We think that those two things should never be mutually exclusive.
Absolutely.
And part of it involves the learning and teaching strategy that we have in the college, making sure that we implement that appropriately, and that comes with 4 strands. So curriculum review, making sure that the curricula are not overly congested. So we just basically meet the learning outcomes, but we don't overstuff them with stuff for the students to do unnecessarily. Things that add volume but not value. It's very important. We make sure that the students go about getting to grips with the curriculum in a deep learning approach. Innovation in learning and teaching, I think we should be at the forefront of that. There is a lot of appetite in the college to do exactly that. And we need to be absolutely on top of diversity and inclusivity. This is one of the key pillars of the new strategy that we have.
I see. So definitely a lot of avenues to explore.
Absolutely.
With this new position.
It's massively exciting. The next 5 years are going to be really exciting for me.
Yeah, definitely. And so a lot of coordination with the leadership team, as you mentioned, and different members of the faculty.
Yeah.
Now, obviously, leading a research group brings with it an element of leadership, and we're going to come to that shortly. But I was interested to know, do you feel that this new position requires a different style of leadership to, say, leading a research group, or do you see similarities?
There are similarities. The research group that I have is about 30 people or so, and I have a really good rapport with each and every one of the members of the group. We may get a chance to talk about that, I don't know. And the reason is because they view my leadership style as a lead by example type. And I think I could bring that to my new role as Vice Dean of Engineering. So for example, if I'm championing a new cause or I'm championing a new idea, I'd like to get in there first. If, let's say, I'm talking about innovation in teaching, then one of the ideas that I want to bring into teaching is the use of virtual reality and haptic combination in order to teach mechanics related modules and things like that. And I want to be the first person to do that. And then I can then comfortably tell everybody else, look, I've tried this, it's innovative, it adds value, our students love it, it really does make a difference. How about the rest of you guys do something like that? And so I view that as a similarity between how I manage my research group and how I intend to do business, if you like, as the Vice Dean of Engineering.
That's really impressive. I mean, you're really trying to emphasize pushing the limits in a way, pushing the boundaries, introducing something new that we haven't seen
exactly before. And pushing the limits myself instead of just telling the others, there are limits to be pushed, guys, and why don't you do it, and I'm right behind you. No, I want to be at the forefront.
Leading by example.
Exactly.
And I can imagine that's a really, really impressive initiative, but that must bring with it quite a challenge in a way, and perhaps something that you hadn't previously experienced, and brings about new challenges every day.
Absolutely. So I think the biggest challenge right now for me is to how to manufacture time. Because in accepting the role, I didn't want to sacrifice any of the other roles.
Right.
So I remained director of research for my department, and I actually view that as an important element of what I do. And I think one of the main strengths of the college is the fact that it does world-leading research, and the marriage between world-leading research and world-leading teaching is what will make us absolutely unbeatable.
Really,
so to have a foot in both camps, Vice Dean of Education and Director of Research, is very, very important for me, and hopefully for the college as well.
No, I definitely agree. And maybe you could share your secrets with me afterwards about how to manage time better. I mean, I'm still learning the tricks of the trade, but I'd love to have a conversation with you.
No problem. Yeah, absolutely.
Before we move on to your research interests, I recently attended the President's address, and President Gus mentioned about one of the key elements going forward was patience in whatever we do, whether it be short-term goals or long-term goals.
Yeah.
What do you foresee in terms of the strategic vision of the college and how we're going to progress going forward?
So the learning and teaching strategy that I mentioned to you is ambitious, and it's nothing that we're going to be able to achieve overnight. Okay, there are elements of it which we can achieve, let's say, at a time scale of about a year or something like that. But there are other elements which would involve a change of mindset, perhaps even a change of culture. And you know yourself that these things take time, and the message that needs to be reinforced and articulated in the same way over and over again. So I think Alice's message about patience is a good one. On the other hand, of course, the world is evolving very, very quickly. The competition is there, and they're not standing still.
Absolutely.
So we absolutely need to have this combination of being ambitious but managing and channeling our ambition in exactly the right way.
Absolutely. Yeah. So I think I speak on behalf of all of us here at ChemEng Conversations, and our department has told me we think we have the right person for the job, and we're very excited to know that someone from our department will be representing the college in terms of leadership, and we're excited to see how the college is going to progress in next year. So we wish you all the best.
Thank you very much. Yeah, thanks very much. I'm going to need all the luck that I can get. Thank you.
So I'd like to move on to talk about a bit about your research and your research interests. So the Matar Fluids Lab has focused a lot on multi-phase fluid flows, interfacial fluid dynamics in different applications. Could you elaborate a bit more on what specific areas you're looking on?
Yeah, thanks. Always a pleasure to talk about my research. So I have to say, my research has really evolved over the years. And so when I first arrived at the college, I was doing a kind of research that's a bit more pencil and paper type, analytical solutions and semi-analytical and things like that. And I've kind of evolved to do things which are a bit more numerical and require use of high-performance computing, parallelization, etc., etc. And so the type of work that we're doing currently involves multi-phase fluid dynamics. So imagine a situation where you have, let's say, a pipe, a conduit, a channel, a tank or whatever, and it has a number of different phases: gas, liquid, solid. The flow structures are immensely complex, and so on. And the application sectors are quite diverse. Okay, and the reason that we could do this is because our research is very fundamental. And so we see the same generic problems across industry, whether it's oil and gas or pharmaceuticals, manufacturing, personal care products, nuclear. We tackle the problem at a sufficiently fundamental level where we are able to address challenges in all of those sectors. And that, I think, is our key strength.
That's really interesting. I mean, a lot of diverse research interests on offer within your group. And I know with the long-term view in mind, your group are working towards two quite large long-term industry-led projects, Memphis and TMF. Would you mind explaining which areas these are targeted towards and perhaps which sort of path they're taking going forward?
Okay, well, thanks a lot for the question. Memphis is a project involving Imperial College and Birmingham, UCL and Nottingham.
Okay.
So it's a big program, it's about £5 million, and it's funded by the Engineering and Physical Sciences Research Council, as well as Procter & Gamble and BP.
Okay.
And so I'm the leader of this program of activity, It started in 2013. It'll end actually this January.
Oh, I see.
And so we're planning, if you like, a follow-up of that. And so this program is very dear to my heart because it embodies the philosophy with which we do multi-phase flow research. And really what we want to do is to make sure that people don't abandon any hope of being able to crack the complexity associated with those flows, and to just adopt a fundamental approach in solving problems involving multi-phase flows. The current philosophy out there is to say, well, the problem is too complicated. I'm just going to do a whole load of experiments and I'm going to fit them to a correlation and I'm going to use those correlations come what may.
Right.
And that is really not a good idea sometimes, because you could be outside the range of these correlations. They could be in serious trouble, particularly if you use them for design. Okay, and so we're collaborating very, very closely with P&G and with BP in order to make use of their case studies and their input into the program, so that we can then translate the results of the program to industry directly. Now, TMF is the Transit Multiphase Flow Consortium, and that's a consortium of about 15 companies, and they tend to be oil and gas companies, so the major oil and gas operators, BP, Chevron, Total, Shell, etc., as well as code developers and software and design houses. They're all kind of part of that consortium that I lead. And that really tends to be really oil and gas. Okay? And so the type of research that we do there tends to be a bit more applied than fundamental, but nonetheless fundamental enough to deal with a wide range of problems that most of these companies are experiencing in the area of flow assurance. So you extract oil, you want to take it from point A to point B, you want to make sure that that goes ahead smoothly, without any complications, as efficiently as possible, energetically, and so we deal with issues of this type. So there.
Very interesting.
And there's a coupling between those two programs, Memphis and TM.
Oh, I see.
Yeah.
Okay. That's interesting. I was also meaning to ask, do you feel that there are any other avenues of research that you feel need to be addressed, perhaps to address the bigger problems, or something that's completely different in the short term or long term?
So that's a great question, because I'm known for fluid mechanics and multiphase flows, as you know, but one of the areas that in my research group that I've been trying to grow since 2015 is an area which is the interface between fluid mechanics and materials. Okay, so obviously you know about graphene or 2D materials, generally speaking, you know about that full well, and you know the importance of that currently, and the potential importance of that into the future. If you think about where those materials are going to take us, there'll be a vast number of applications involving them. So at some point we have to produce them en masse. We have to produce them with at a high rate, and we have to produce them in a reproducible manner. There are different types of 2D materials, and the group now, a part of it, is really working on the issue of scaling up the production of 2D materials of a certain kind. So can you engineer a flow field that can guarantee you a 2D material of a certain property at a high rate? The issue of scale up. And as a chemical engineer, we deal with those types of issues all the time. So devising a continuous scale up solution for the large scale production of 2D materials is very much on the agenda for the research group now, for my research group. The other thing that the other space that I want to play with is biological space. And so I would like to get into the area of antimicrobial resistance. So how do you deal with biofilms and things like this? And that's a problem that's been around for quite a lot of time, and there's been quite a lot of research done in this area. My group has never really played in that space, and yet I think that we have a lot of things to say about that. If you think about a biofilm as a material that could potentially flow, it could, if you stress it, it'll deform. It can deform in a particular way. If you think of it this way, then suddenly it becomes a problem that we can address. And then we can ask the question, how does a biofilm interact with flow? Can it be removed through flow? How does that come about? Etc. And there are a number of people in the department that I could work with in the Faculty of Medicine, Life Science. I think it's going to be a very, very exciting area.
Sure.
Yeah.
And again, coming back to your previous point, this may not be the point of emphasis of your research group in the past few years, but again, it's this case of pushing the limits, pushing the boundaries, and going into the unknown.
Absolutely, yeah, and adopting a fundamental approach when you do this.
Sure.
It's very, very.
So I'm sure you'll agree that our department boasts some state-of-the-art facilities, that carbon capture pilot plant being a prime example. And what facilities would you like to highlight for the fluids division, and in particular your lab, that perhaps our audience, prospective PhD students or postdocs looking for applications might be interested to be a part of?
So, another great question about the facilities that we've got. So, of course, we have the pilot plant, and that is really a facility to be proud of. Now, in terms of our laboratories to do fluid flow experiments, first I have to say that I would regard myself as primarily a modeler.
Okay.
I'm someone who abstracts a problem, writes down the equations, invents ways of solving these problems, and my tendency is to attack the problem analytically, computationally, theoretically, etc. I do experiments, and I have to say that I work closely with collaborators. So I want to mention Dr. Christos Markidis in our department, who's a brilliant researcher, and I work very, very closely with him. And the laboratories that we have are, one of the main aspects that I want to highlight is the fact that we are using laser-based diagnostics in order to get fundamental information about flow fields, which would tell us about the fundamental physics underlying the macroscale phenomena that we observe. So, and that's extremely important. So I remember when I arrived back here as a lecturer back in '98, the type of fluid mechanics research that we were doing was really one where we would look at a macroscale event or a macroscale phenomenon or a global parameter like a pressure drop, which hides all kinds of very interesting and important physics. With the laser-based diagnostic tools that we now have, we can really probe the fundamentals and ask the question, why does a flow transition from one regime to the next, with all the implications that has. And I think that's really what makes us very, very strong, particularly if you couple that with the CFD tools that we're developing. That's really a winning combination.
So definitely some very impressive facilities on offer, and I think it's always very exciting for us, for prospective students, even myself, just to drop by now and then and see the work that you guys are doing. So we're very lucky, as Professor Matar has actually arranged for us to have a lab tour of his facilities, and it was kindly led by his PhD student Andreas, who invited us a few weeks ago. We took our camera along and we were able to film our tour, and we provided it for you as a short clip in our episode, so please do check it out. So hello everyone, we're here outside the Matar Fluids Lab in the Department of Chemical Engineering here at Imperial College. We're about to receive a lab tour from some of Professor Matar's students, which they very kindly organized. So here we are, let's go in and let's see what they have in store for us.
Hi, my name is Andres. I'm a PhD student working under supervision of Professor Omar Matar on multi-phase flows. For my current project, I'm studying the behavior of two-phase interfacial film flows in vertically orientated pipes.
Hello, my name is Stuart Wright. I'm a PhD student under the joint supervision of Omar Matar and Christos Markidis. I'm studying mixing of stratified liquid-liquid flows using Jackson crossflow.
Hi, my name is Ajay Gupta. I'm a postdoc working with Professor Omar Matar. I'm doing experiments on the startup of lubricating greases in long pipelines.
So we just heard from Ajay, a postdoc in Omar's group, talking about his work on multi-phase fluid flows. We're here with Stuart. Now Stuart, I understand that you also work with multi-phase fluid flows, is that right?
Yeah, I study liquid-liquid flows. For the oil and gas industry again. The purpose of this is for transaction in valuation of crude oils, etc. And the main purpose of the experimental work is mixing of these stratified flows, because when you have stratified flows, there is no single point of measurement where you can take a representative sample of what's actually in the pipe.
Sure.
So we mix it, and providing the mixing most economically.
I see.
It's the important side.
And is your work primarily experimental, or?
It's more experimental than simulation, although I do a bit of both.
I see. Okay, so that's quite useful for our prospective students who might be interested in joining Omar's group. They do a lot of work, both experimental and simulations. So this is quite a rig you've got here. So what's the purpose of this setup?
So there's a pipe that produces a stratified flow at it's 8.5 meters long.
Okay.
It produces a stratified flow, and then we have a single jet here, which mixes this stratified flow, and we can control the flow rates, the water fractions, and the speed of the jet. And then we use lasers and high-speed cameras to observe these flows and the subsequent development of these flows as they go down the pipe. This allows us to obtain the water fractions, droplet sizes, and velocity fields for the flows.
Wow, that's very interesting. So very interesting research that's taking place in your lab. Would you mind explaining what sort of industrial relevance your project has, either in the short or long term?
So we can create many different flow regimes in the vertical pipe indeed. And for instance, taking one flow regime, annual flow, this can be met in many different applications, particularly in oil and gas industry, such as the risers, transfer pipes, as well as the gas liquid oil wells.
I see.
Now, to be more specific about the process units, these are also can be found in chemical reactors, in distillation towers, as well as evaporators and condensers.
I see. So it's great to see so much industrial relevance with your research, and it is definitely very interesting. So we wish you all the best, and hopefully it goes well.
Thank you.
So there you have it. That was a quick preview of the cutting-edge, high-impact research being conducted in the Matar Fluids Lab on multi-phase fluid flows and interfacial fluid dynamics. So if you'd like to get involved with this research, and if what you've seen today interests you, please do follow the links to the Matar Fluids Group website and all their social media channels on your screen, and also in the description below. A big thank you to Professor Matar and his team for having us today on ChemEng Conversations. We look forward to bringing you many more tours of the state-of-the-art facilities in our department very soon. Until then, see you soon. So, a very interesting lab tour. Thank you for giving us the opportunity to film in your lab, Omar. It was a real pleasure, and thank you to Andreas for arranging the tour for us. I had the privilege to share an office with plenty of your students, and we interact on a daily basis. And whenever I interact with them, I have to say, all I hear is always positive feedback, praise, about how much fun it is to work in your group. The research is, keeps them going every day. It's such a motivation to work in the Matar Fluids Lab. And I think that's really encouraging to hear, because that's what you want at the end of the day. You want the students to have a good time, but also make progress with their research. And I thought I'd ask, what do you feel are the key values to achieving a positive team dynamic, and how have you been able to achieve this?
Well, it's really good to hear that. I think fundamentally I love my research group. I really care about the students and the postdocs and the MScs and the undergraduate research students that I have with me as individuals first before they're researchers. And I think that's really the winning formula here. You've got to look at a person, understand what their motivation is. What are they trying to achieve? Why do they want to do their work? What is it that they want to do, if you like, in the future, and help them achieve that. You need to be in touch with their hopes and fears and dreams, etc., and support them. I don't think I've ever asked a student to do more than their limit, so they understand that. The other thing that we do is we try to have a team dynamic, in the group. So quite a few of the students and the postdocs share a common problem, so multi-phase flows. And those problems could be computational, could be analytical, could be experimental, and so they kind of collaborate together. So there is this bonding at a fundamental level in order for them to crack their problems, and that really does come out in the discussion. The other thing that we do is, even though I've got a team of about 30 people, I meet with them very regularly. So it is unlikely, unless some of them are co-supervised by other colleagues, and if the other colleagues are their primary supervisors, chances are very often they meet with them more than they do with me. But if I'm the primary supervisor of a student or a postdoc or whatever, then I would meet with them on a weekly basis. And if I can't, then I will make up for it. So I very rarely let people go to drift.
Leave lead them on their own.
No, and it's not because of control freakery,
Sure.
it's because I'm genuinely interested in what they're doing. And of course, you've got to do this very carefully. So initially, I'm with them all the time. As time progresses, eventually they will know more about their subject than I do.
I see.
And I would go to them, I would consult them. So the dynamic really changes. But they should know that I'm with them every step of the way. And I think that's very clear to them. And
Sure.
maybe that's the reason why they like working with me.
Sure.
And they're working with me, not for me.
Sure. That's the key
That's the
emphasis.
key,
You want to work. You want to emphasize that team culture in a way.
Exactly right, yeah. There's not like there's a boss and there are subordinates. It's not like that. It's all very flat.
Sure. And I'm sure that's very encouraging for our audience to hear as well. To achieve something.
To achieve your goal. Yeah,
Sure.
exactly.
Now, speaking of achievements, you've obviously been part of the Imperial Imperial College framework for quite a while now. You studied your undergraduate studies here, and
did.
then joined again as a lecturer
Yep.
after a short break for your PhD.
Yep.
And then has made it all the way to professor now, and then vice dean.
Yeah.
What do you feel is the most proudest achievements in your career to date?
Well,
or is it difficult to pin down one?
I'm hoping that the proudest achievement will be the achievement that I'll achieve next year or the year after that, or So I'm hoping that there's still more for me to do. Being vice dean was obviously one of the highlights. Okay. Being voted as or winning the Saka Award in 2014. For the undergraduate teaching across Imperial, for me that was a major highlight.
Yeah.
I was smiling for weeks and weeks. And if you've been to my office, you know that my office is very Spartan, right? There's
Sure.
not a drawing on the wall. There's nothing, etc. But for a very long time, I kept the award that I got for UG
really?
teaching, and I kept it on display until I moved offices, etc. And I put it back.
Yeah.
But that's the only thing that's on display.
Wow.
I'm very proud of the fact that my department, when I was Director of Undergraduate Studies, was ranked number 1 in the National Student Survey in the NSS, 97% approval. That's also very good. I'm proud of the fact that I'm a fellow of the American Physical Society. That's an honor bestowed upon less than maybe 0.5% of the membership of the APS. So I'm proud of that. And also proud of the research that my students do, a number of whom have managed to get lectureship positions.
Oh, that's
I'm
wonderful.
very happy about that, yeah. I view that as a metric of my success. How many people I can help, I can coach and nurture so that they can become lecturers, professors like me in the future.
Wow. So definitely a lot of proud achievements to cherish and also more to perhaps look forward to hopefully in the future.
Yeah, that's absolutely.
Yeah. Now, you mentioned about how things have evolved quite a lot in the department, particularly for your group and for the department as a whole. When I joined in 2012, and that was the year when we had just launched the carbon capture pilot plant.
Yep.
So for me, coming as a new student straight out of GCSEs and A levels, and seeing this 4-story huge plant, that was very exciting for me.
I can imagine. Yeah.
But for you would have probably seen the inception, the development, and the launch of it. So how do you feel the department has evolved?
Well, so I'm very proud of what the department has achieved over the years, and I can tell you that the department actually did have the foresight of having a carbon capture plant commissioned in the early 70s. So we were way ahead of our time. Yeah, so the old pilot plant was doing exactly that. But of course, that plant was getting to the point where it really needed to be retired, and we needed to put a new one in place. And I was director of studies at the time when that happened.
Okay.
And so the decommissioning, the commissioning of the installation of the new plant, the commissioning of the new plant, the rewiring of the curriculum to make sure that everything is exactly as it should be, even though that pilot plant was offline at that point in time. I lived that through those times. And eventually we transitioned to a department which is super modern, has this wonderful facility, etc. And that, I think, is also a reflection of our evolution.
Sure.
So the department, more than ever, wants to be the best department, chemical engineering department in the world. And we want to be leaders in terms of not only research, but education and looking after our students. And again, for me, to be a vice dean at this exciting time is very, very important for me, very exciting. And so the discussion now in the department is how can we be the best? How can we do the best possible for all members of the department? The students, support staff, the staff. That kind of level of thinking is something I'm very proud of, and I've really witnessed the evolution of the department from a department that was very, very, very strong, very good, to really thinking about being top-notch, absolutely the best in the world. And I'd like to play a role in achieving that. Of course, as Vice Dean, my remit is across all of engineering, not just chemical engineering, but I remain, of course, very proud of my home department.
Of course, sure. And if we're looking at trying to become the best department in the best chemical engineering department in the world, if you could summarize 3 key words that you would try and instill into all the staff and students to say, we can achieve this goal, what would you say?
So again, it goes back to the words that you mentioned before. It has to be ambition. You need to have this burning desire and ambition to be number one. And with that, I mean, you could take examples from the world of sports. You understand what it means to be number one. It's not just the talent. Right? I think we have the talent, but you need the hard work. You need the perseverance. You need to have confidence that you're going to get there in the end ahead of everybody else. Those things are very important. But also you need to make sure that you take everybody with you. So that means that you need to listen to people. You need to communicate with them at all times. You need to make sure that they're on board with the ideas, so that we all head there together eventually up the mountain. You can't leave anybody behind, no matter who it is. You've got to take everyone with you. Everybody has to understand what the message is.
And everyone has to be working towards the same goal. So
co-aligned. Everybody has to be co-aligned.
Sure.
Right? And they have to do that genuinely. They need to be convinced that there is this cause that we're pursuing, and everybody has to be co-aligned.
Sure. So before we move on to a few questions about Professor Matar the person, as opposed to Professor Matar the academic, I thought I'd just ask one final question because it's something that's quite personal to me as well.
Yeah, sure.
So I had the privilege of being taught by you as an undergrad in my final year. A course I enjoyed very much, and seems only like yesterday actually, to be honest, even though it's already been 2 years.
Yes.
When you look at teaching, you've obviously mentioned that it gives you a lot of satisfaction and enjoyment.
Yeah.
Do you feel that there's anything specific you'd highlight that sets our department apart from, say, other departments?
So, I have to say that when I was Director of Undergraduate Studies, I had a chance and the privilege to work with my colleagues, Director of Undergrad Studies in the other departments, and I came to know the wonderful things that they do over there. So I wouldn't say that ChemEng has exclusivity on being excellent. I think there are other departments that do some fantastic things and things that we can learn from. But in terms of ChemEng education, let's just think of it this way. This department had the foresight of thinking about the concept of mastery more than 20 years ago, and that's a concept that people are copying now. Copying is probably not the right word, but adopting, and reverse engineering for their purposes in the college and across other ChemEng departments in the UK and in the world. And so the idea that, as an engineering student, ChemEng student in particular, there are a number of things that you need to be able to know, only a few things you need to be able to master. And so the separation of the mastery level knowledge from everything else, and making sure that whoever walks out of here with a degree really absolutely knows and has assimilated that kind of knowledge is something that is pretty unique to our department. And that, if you like, embodies the way that we approach our teaching. We approach it from the learning outcomes first. So we try not to overstuff our curriculum to the point where the student just gives up, meets deadline after deadline without actually engaging with the subject matter. And I think that that's very important and aligned with the strategy of the college.
Sure. Because you need to enjoy what you learn, obviously. It's not just
absolutely.
It's not just for the exams, for the grades. It's actually appreciating the opportunity you've been given to study the subject.
100%. You need to have the time to assimilate it so that the knowledge is really part of you.
Sure.
And so, I think that's one of the key things that we're doing.
So thanks very much, Omar. It was a really interesting discussion about your career, and I've learned a lot as well, because there's some things I didn't know about your achievements especially.
Thank you. That's great.
So as you know, on ChemEng Conversations, what the unique part of our show is that we like to tailor in our conversations towards our interviewees. We like to get to know them on on a bit of a personal level. So if it's okay with you, I thought we'll just ask a few fun questions.
Oh yeah,
Just-
absolutely.
Just to get to know you as
Yeah.
well.
I have to say the other questions were fun too. So
Oh, I'm very glad to
wasn't
hear that.
just,
I'm very glad to
yeah.
hear that. So, so what inspired you to study chemical engineering?
that's a great question. I've been asked this before. So I have to declare that initially I wanted to study astrophysics, and,
Oh, really?
and I'll describe why. It was a time where Brief History of Time had come out. You know, the
Stephen Hawking.
Stephen Hawking book, and working for NASA and working in space, and you know the space shuttle program had started, etc. That was all the rage. So if you're somebody who was decent at maths, decent at physics, etc., you had these ambitions
Sure.
to do all these things. And so my ambition was really to study cosmology. I wanted to do that. These things called black holes, you know, was very interesting. But then I started to think to myself, right, what am I actually going to do post-graduation? And I always knew I would become an academic. I always just knew this, you know, and that is, I think, a blessing for me, because I didn't have to think about jobs after that. I knew what I was going to do. Then I thought to myself, okay, if I'm a cosmologist, because I'm going to be doing these wonderful things, but can I make an impact on everyday life? And with all due respect to people who do cosmology, it is, I would say, probably difficult to translate their wonderful research to things that could affect the two of us on a daily basis. And so then I started to think about engineering. And then I started to think about, you know, so I read prospectus, just that, like everybody, every prospective student, and I came across ChemEng and the versatility of the chemical engineer, and all the things that they were, you know, kind of picking up during their degree: maths, chemistry, physics, materials, theory, modeling, computation, etc. I thought to myself, well, you know, if I get in there, then I could achieve anything I want thereafter. Probably including doing research in mathematical physics and what have you, kind of what I'm doing right now. And really for me that course kind of stood out. Now, of course, the other courses that we have in the faculty here are fantastic, as you know. But ChemEng really did speak to me. And I thought to myself, you know, armed with that degree, you know, there is virtually nothing that I can't achieve. So I chose ChemEng. And I chose ChemEng at Imperial in particular. You may or may not ask that question, because I always knew I'd come to Britain.
Okay.
I always knew it. So I had an affiliation with the UK. Quite a few of my friends were British, and for me, I always wanted to come to London and see what it was like. So I only applied to effectively London schools.
I see.
In Imperial, when I first heard about Imperial, it was effectively love at first sight. You know, it was one of the people that went as a senior in my high school, was a friend. We were very close. She told me she was coming here. She told me about the place, and I wanted to come to Imperial College. And then when I realized how good Imperial are at chemical engineering, I thought, this has to be the place for me.
This is the place.
This is the place, yeah. And so I came. That's it.
It's a very interesting story. I had no idea about you wanting to come to Imperial for these reasons.
Absolutely, yeah.
Really interesting. So I guess that kind of answers the question which I had lined up next, which was, if you hadn't become a chemical engineer, would you have become a cosmologist or perhaps some other profession?
Yeah, so perhaps. I often ask myself that question, although I have to say maybe another career in a completely different field. For example, working for the United Nations or in politics to do good, that kind of thing. Something in a completely different space, I would say. So if ever, which is never, but if ever I were to quit academia, I would imagine maybe trying to work in that kind of space, try to, you know, to do good in other parts of the world, in developing countries, things like this. You know. So in fact, we're doing research right now to try to benefit developing countries. So I can imagine perhaps later in life, if I got out of academia, to be in that space. But right now, I can't imagine being anywhere other than here.
This is your place.
Say, yeah, exactly.
Yeah, that's really nice.
Yeah.
And how do you often spend your free time outside of work?
So, you may know that I have a young family.
Yes.
So I have two children. One of them is 4, the other one's 2.
Wow.
And so the weekends are taken up by the two. Yeah, exactly. So So we go to various places. They've been signed up to do, you name it, right? Swimming, ballet, drama, gym, football. And so by the time we've covered all that, that's your weekend.
It's Sunday night. It's time to prepare for the next week.
Yeah, so exactly right. And so actually I end up doing some work during the weekend. Perhaps I shouldn't, but you know, the work hours are such that that's sometimes a necessity. So after they go to sleep around 7:30,
Sure.
then I start to do them. But the rest of the time I'm with them,
Yeah.
as I have to be,
Sure.
as I want to be.
Yeah. Is it quite tricky balancing the work and commitments to at home as well to the family? Do you think?
I'm not going to lie to you. It is hard work, you know, but it is something absolutely worthwhile. I want to be there for my children growing up, just like I want to be there for my research group when they're growing up in another space. I'm not saying that my research group are children, but I think you understand. What
No,
I'm
I
saying.
absolutely understand what you're saying.
And for my kids, my own personal kids, every day is different now. They're picking up new things every day. So I go home, and my 2-year-old in particular surprises me with new words that he's able to say, often quite complicated words.
Wow.
Quite frightening when he does that. But
Is turbulence one of them?
turbulence is one of them. Yeah, mathematics is the
Okay.
other one. Engineering is, I think, another one as well. Anyway, so you can imagine it's a very exciting time, and I want to make sure that when they grow up, they know that Daddy was around. You know, when we were growing up, and he wasn't off at work or a conference or whatever, never really saw him. I never want that to happen.
Sure.
And I want to make sure that will happen.
And can you see yourself perhaps at your children's graduation, perhaps even here in Imperial?
So I get asked that question quite a lot, which is, you know, do you want your daughter and your son, Vivian and Leo, to become engineers or chemical engineers? Do you want to come here? Do you want to teach them? Do you want to co-write papers with them or whatever? And I have to say the idea is attractive.
Okay.
But for me, what would be more attractive is to see them happy in excelling in whatever field they choose. So Vivian has a fantastic left foot. She's a great football player.
Really?
Right now, yeah.
Excellent.
She's 4 years old. She dribbles, she passes, and she's left-footed. She's right-handed and left-footed.
Yeah.
And England need a left-sided player. So I mean, if she were to go into football or whatever,
Encourage her.
I'd be very proud.
Yeah,
I'd be very
absolutely,
proud.
absolutely.
Yeah.
Yeah. It's really encouraging to hear, achieving that balance between family.
Yeah.
Now, this is an interesting question. I think someone asked me this quite recently. I had to give it quite a lot of thought, to be honest.
Is it?
If you could choose anyone from past or present, scientific or non-scientific, to be your dinner companion, who would you choose and why?
Oh, dinner companion, yes. So is my wife listening to this conversation? Okay, so it has to be, well, it's either Barack Obama or Rihanna. I'll let you pick.
Funnily enough, I had Barack Obama as one of my
so,
choices.
So Barack would be great to, you can imagine, you know, as great as he is somebody that you may be able to have a really good conversation, genuine conversation with over dinner if you can get hold of him. He's
busy man.
You know, he's a busy man, probably maybe a bit less busy now. But certainly it would be fantastic to pick his brain in terms of his evolution and what he's done and how he's managed to get to where he got to at such a young age. Right? He was President of the United States in his 40s, and how he's managed to have such an influence on people, to touch people's lives. I remember when he was elected, random people were texting me, congratulating me on his win in the presidential election. Crazy things like this were happening when suddenly he became president. He was very much everyone's president, I think.
Sure,
And that was
people's
amazing. Yeah, people's president. I listen to a lot of music in my spare time. Pop music's one of them. Rihanna's very good.
Absolutely, I'll agree with that one.
So it's either Obama or...
That's really interesting. If you had scientific?
So scientific... you know,
I chose Isaac Newton.
Yeah, Isaac Newton would never have dinner with me. I can't imagine. So Newton was a very special character, and I'm not sure he had many friends.
Bit of a quirky.
So if he ever responded to his emails, I would
or his
try to.
parchments and quilts.
Or his parchments and quilts. Yes, Einstein is probably everybody's. But you know that there are some successful chemical engineers that I. We had the opportunity to have Bob Langer from MIT over here.
Yes,
maybe 2 or 3 years ago. He's a wonderful person, and he's done amazing work starting his own area where he could have been just as successful in the more traditional area, so the area of borrowing ideas from chemical engineering and using those in the medicine space was really something that we owe to him, and he's made fantastic strides in that area. So, having a one-on-one with him would probably be a good thing.
Well, I can imagine that'd be a very interesting conversation.
Yeah.
A bit like how I'm having now.
Thank you.
So, one thing I wanted to ask was, since we've both studied the course at ChemEng, or perhaps it's slightly different how it is now and how it was when you were studying, but when I finished the course, it was, I'm not going to lie, it was very challenging, of course, because Imperial pushes you, but very rewarding at the end of it. And when I think back on it, I always think, what were the real highs and where were the parts where, things weren't going so well, I had a tough day, tough exam.
Yeah.
For you, what was perhaps one of the toughest exams or projects you remember working on?
So the toughest project is probably the final year design. You had that experience, which is our capstone project. It's an 11-week project where every day seems like a marathon. It's an endurance test. It's a really tough thing, and that's it's memorable. I still remember everything that I did, and the people that I worked very hard with, and the competition between the groups, and all of those things. I think that's tough. Lots of highlights, and I would say there are academic highlights, but the people that I met on the course, many of them remain my friends to this day.
Oh, that's great.
To the level where I was best man at a wedding, that person became godfather to one of my children, that kind of thing. And that's the kind of spirit that I want to make sure is the spirit with which we run our courses. So I want every student to have the experience that you and I have had, which is a great course, make great friends, wonderful memories. That's what I want for everybody here. And I'm going to work very hard to make sure that happens.
Sure. It's really encouraging to hear that friendships, that's the most important part. You want to meet good people, but stay in touch after the
That's
course.
priceless. Yeah.
Absolutely. So I thought we'd play an interesting game, let's say.
Okay.
So what I'll do is I'm going to give you a few keywords or phrases, and I'm just interested to know what your immediate reaction, your blank reaction, let's say, to these are. So, okay. Imperial.
Better
so,
sit down for a minute.
Yes, better get ready for this one.
Yeah.
Okay. Imperial College.
Home.
Okay. Fluid dynamics.
Career.
Okay. ChemEng Conversations.
Fun.
Thank you. Very glad to hear that. Manchester United.
Passion.
You're a Manchester United fan, correct?
Yeah,
okay.
I am.
We'll probably discuss that.
Okay.
Academia.
Journey.
Okay. And teaching.
Achievement.
Good answers.
Or inspiration.
Really good answers. So before we wrap up, just one final question, which I think would be quite useful for perhaps a young audience or someone just starting their career. Given your experience, throughout your academic career and beyond that, do you have any advice for any student or any individual just starting out their career, and perhaps some advice you would give them? So
I guess the answer to this question is very similar to the answer I gave you to a previous question about success, about our success in the challenges that we face on a daily basis. And again, I come back to the idea that this is a marathon, not a sprint. If you imagine that things are going to succeed from day one and you're going to be on a purple patch for the rest of your career, you're very much mistaken. You need to be able to I'm not saying derive pleasure from some of your failures, because that would be really perverse, but to always treat them as a learning process. Never take things personally. Imagine that other people are going through the same growing pains as you are, and try to remain positive. I think the most successful academics that I know are the ones that still want to play. They still want to play. They still are childlike in their curiosity about their field. Very, very passionate. They wake up thinking of new ideas. They stay fresh. Their bodies are getting old, but their minds are still fresh. And you need to resist the temptation to become cynical and jaded. Because there'll be challenges, there'll be things that you put your heart and soul into that will fail. But you need to say, well, I may have failed, others have succeeded because they're too good in this particular case. But I could do better. I could learn from this, and ultimately I will win. You need to have that. That's very important. And it's easier said than done, but that would be my advice.
Very, very good advice. And with that, I'd like to thank you very much, Omar. It's been a wonderful conversation. Thank you for coming on ChemEng Conversations. It's been a pleasure having you.
Thanks for having me.
So that wraps up our first episode of ChemEng Conversations. We had a wonderful time with Professor Omar Matar on the show. If you'd like to get in touch with Omar regarding research or any other interests, all the details are on your screen. We have the Twitter handle for Omar's group at Matar Lab. We have the website, and we have also Omar's email address if you'd like to get in touch with him at any point. Are you easily contactable?
Yeah, everyone knows they can reach me by email. I even have my own Twitter handle, OKMatar, at OKMatar. And there is also the Twitter account for Imperial Engineering, at Engineering.
Okay.
So I handle that account as well for engineering. So I'm imminently contactable, so please do get in touch.
Perfect. Well, there you go. So without further ado, I'd like to thank you again for listening. Do get in touch with us. We'd love to hear from you about ChemEng Conversations, about our show. Hopefully you've enjoyed our first episode. Do interact with us using our Twitter handle at Imperial ChemEng, and our hashtag is #CE Conversations. We'd love to hear from you. But until then, it's then. Oh, shoot. I still the last line.
Just do like the last bit again.
Okay.
So just do like the
What? Okay.
Imperial College London.
Okay. So we'd love to hear from you, and we'd love to know how you enjoyed our first episode. So do get in touch with us. The Twitter handle for the ChemEng department is at Imperial ChemEng, and you can get in touch directly with #CE Conversations.